So the first case study that we're going to go over today is that of a water heater manufacturer. Established in 1975, the ELA's Domestic Appliances Production Industry and Trade Incorporated Company, also known as IHEVA, started in small appliances. They highly take into consideration human health as a priority. The company currently produces cleaning robots factories, water heaters, and RO water purifiers. They also do carpet washing machine factories and plastical injection printing plants. The production of a water heater occurs in 31 steps initially, and each step is taken by a different operator. The company produces between 9,000 and 31,000 water heaters in a month on demand. However, they can only produce water heaters every other day and produce a different product on the off day. Sometimes they've noticed that this makes meeting orders hard to obtain. So as I just went through, initially before their VSM, they had 31 steps, all done by different operators. One of the things that they noticed was that the wait time between operations or stations varied quite a bit. Many of the workers sat on the job, or even when they were waiting for a part to come to their part of the line, they were sitting on the job, kind of just hanging out until they had work to do. And besides that, there was also a lot of clutter in the workspace, so if they had to move anywhere or move between units or stations, they were moving around things or obstacles. So the plan of attack was to do some VSM and a few more, which I'll get into a little bit. So here on this slide, you can see the initial map and the operations outlining each of the 31 steps which they went through, and then you can also see that their assembly line is in 31 different pieces, kind of in a horseshoe or a U shape. Also in this map, it shows the dimensions along the bottom, so you can kind of roughly see how far each of these units are apart. So then if we go to the next slide, after they did the VSM study, they were able to do some space savings, which we talked about in earlier lectures. So you can see in this little picture here what kind of space savings they did. They went from a total of 100 meters squared to 60.5 after the application of a Kaizen procedure. So that amounted to a total of 39.5% space savings. Then the next thing they did was, after the value stream mapping, as I'd mentioned before, there was a lot of workers that had a lot of lag time in between duties, so they did better work allocation. Whether this entailed maybe giving somebody at the beginning of the assembly line another task to do farther down the line, or maybe taking a task that had like a lot of work duty to it and kind of giving a person that didn't have so much responsibility, maybe giving them more, and kind of giving more people or some people a higher load and relieving others. So in the end, this also reduced the wait times. And in the article, which you can find in our references section on one of the last slides, you see they drew cycle time towards takt time. And they also promoted standing while working, which kept the workers engaged, and so maybe when the part actually did get to their unit, they were ready to go, and there wasn't so much lag time with the workers themselves. So how they did it? They did the value stream mapping, which we're talking about today. They also implemented a Kanban system, which we've talked about in previous lectures, or actually just pretty recently. They did space management, which you can see in this table right here, cycle time calculations, and they also encourage better working. So this application in water heater manufacturers shows that the value stream mapping is a very useful tool to realize potential improvement opportunities and constitute lean systems. In the workshop, there's a significant amount of time spent on the manufacturing from weight and non-value added operations, and this is some of the operations that they were able to reduce. The most salient problem under the existing circumstances was the differences in cycle times and remaining below the takt times. The main source of the problem is unequal distribution of workload, as I had mentioned earlier, and the flow among the operators and the unnecessary waiting times. Again, this is where the workers were sitting and kind of just hanging out and being idle in between their tasks. The other problem is the changing nature of production demand and time. So if we go on to the next slide, by doing the value stream mapping, they're able to spot extravagancies in the production process, ultimately bringing their lead time from 28.3 down to 9.4 days, which is pretty remarkable. So on the left, you can see is their value stream map prior to their analysis, and it's pretty complicated. You can see where there's units that are waiting on previous units, lag times. It's pretty complicated. And then after the value stream mapping and after their analysis and implementation of the changes, you can see that is a lot less complicated. A lot of the clutter's out of there, and they had a pretty successful lean system implemented. So.